Okay, so now we're on to question number 4. Question 4. Draw the major product formed when the following epoxide reacts with aqueous acid. Use wedge/dash bonds to show the stereochemistry of the product. Okay, so let's write this down. So we got some stereochemistry involved here. And then this triangle with the oxygen at the top is called an epoxide. It's a very strained molecule. So ideally it wants to, the ring wants to break apart. And it typically does so when you add like acid or even base. So I'm just gonna write that down just to give some background information. So epoxides are reactive, and this is due to ring strain. Then that ring opens up upon addition of acid or a base. Yeah, so I'll write down the mechanism down here. So I'll just write this as like an R group. It's my epoxide. And then you can write the H3O plus kind of like this. It's pretty much a protonated water. And then what happens is that one of the electrons on the oxygen comes and takes that proton. And then you end up with this positively charged epoxide. And then from here, I'm gonna draw the resonance structure of this molecule. And then I'll explain why this resonance happens in a bit. Okay, so as you can see, the positive charge that used to be on the oxygen has moved to this tertiary carbon, and that's because this structure is more stable than this positively charged epoxide ring. So I'll just write that down. So this forms a stable tertiary, and this is what's called a carbocation. And then what happens next, that you have water molecule come in, and then it comes and neutralizes that carbon. And then you end up with something looking like this. I'm going to draw the stereochemistry that happens. And now this oxygen is positively charged. And then from there, you have another water molecule come in. And then it's gonna deprotonate that to relieve the oxygen of the positive charge. And then this gives us our final product. Okay, so I'm just gonna write down what that looks like here. So just to complete this, give our final answer. Basically, that epoxide ring opened up. And then these are our two methyl groups that were there. And then we have a new alcohol group at the end right there. So let's see what our junior tutor said. Yep, so they have this, and then they didn't really show the stereochemistry here, but it's still the correct compound. I'll just say the solution is correct. Okay, solution was correct.